Welcome SSC220 students. This is my week 10 commentary as we return from the spring break. This is our second of 3 weeks of working on statistical ideas or tools with which we evaluate published materials such as the image on the front of our website here. In the first, you'll recall that the theme of the first week was getting a handle on descriptive statistics and the kind of standard ways of summarizing data that is collected from samples or even whole populations. This week we're looking at not describing, but rather the issue of prediction. And so we call these inferential statistics, inferential meaning inferring a prediction. Now, just as a consideration here, note that prediction is not always about the future. We can predict what we will find in a history book. We can predict what we will find in the library. So prediction is simply going beyond our immediate experience and finding out something that is elsewhere, as it were. That being said, we begin with the basic tools of correlations and t-tests this week. Correlation is the image here, and of course you've all heard that a correlation is a relationship, and so there are different characteristics or features of the relationship that one can determine based on the correlational statistic. The single statistic that you need to put into long-term memory is R. R is Pearson's correlation coefficient, and it's the numerical summary of the correlation. So you see an R on this page, for example, of 0.9971, and then you see a probability or p-value after that. Notice probability, it gets back to the question of prediction. Okay, the basic theme here is one you see in introductory level courses, which is correlations are relationships, but they are not causes. So think about relationships between variables that are there and that are strong, but are not cause and effect. That's a new kind of thinking for some students, and so being clear on that is important. Again, the example here is looking at this graph of measures of autism and organic food sales. We see that there is definitely a relationship, but we do not conclude that organic food sales cause autism, although some might take that position. Okay, so correlations, and then you get to t-tests. T-tests are simply comparisons of means or averages in two different samples or in a repeated sample. In other words, two sampling efforts. And when you're comparing the descriptive statistics in those two different efforts, then you're probably going to use a t-test at least to start with. So it will tell you whether the average of one sample, in fact, either predicts or is linked to the average in a separate sample. So look at t-tests this week and look at R's and think of them as statistical ideas. You do not need to know how to calculate them, and that's important. Also this week you're looking at the difference between practical or clinical prediction versus statistical prediction. So statistics are only mathematics, and hence we know that something can be statistically significant but not clinically or practically significant. Finally, you'll be introduced this week to analysis of variance, which is really the most complex statistical tool that you'll encounter this semester. So it's the last and most complicated one. And basically it's very similar to a t-test in that you're interested in differences between averages in different samples. More about that when you read it in the patent text. So it's steady on, and then next week we'll take one more look at statistics, and then we will be done, and we'll return to the subject of research designs. So let me know if you have questions. I've asked you to comment on trigger questions this week and employ examples to illustrate both what you do know and also what are called muddy points, or points of confusion. You'll get full credit for those muddy points because it's contributing to our class discussion. And I think it will help others as well. So I think that's enough for now, and I hope you had a good spring break. And we're about 5 weeks now out of the end of the semester.